Okay, so we are supposed to load the file, and then after loading the file into our Power BI, the next step is to clean the file. And then from now cleaning, we move to transforming the data. We transform the data within that data set. So for me, the file is already downloaded, so I would just upload it into my Power BI. So I'll use the get data as usual. And in this case, we are working with an Excel workbook. So I'm going to choose Excel workbook because that is what I downloaded. So I'm going to choose on that. And then you're going to pick it from where you had stored it. Yes, I have it in my downloads. Yeah, it's here. So we wait that to load. So once the data loads, we are supposed to proceed to cleaning the data. That is the next thing, cleaning the data. In most cases, data cleaning is very, very important because sometimes the data that we usually have is messy, containing errors, typos, and so many other values that are not supposed to be there, or even values that are incorrectly stored. So we have to clean the data to ensure that what we have is something that is that we are able to work with. So in this case, we can see that our data is still loading, and this was an Excel workbook. So it's going to load. It's having so many, different tables. So once the data finishes loading, we are going to select on the different tables that we want to use within our workbook. So we can just select on all the tables, You can select all the tables. I hope you guys are able to see the pop-up. Are you able to see the pop-up? The tables that I'm selecting? Because I can't see my screen from here.
We can see them. We can see the tables.
Okay, thank you. So now we have something here. When you click each and every table, you'll be able to see a preview of what the table contains. So we can transform the data, or even we can just visualize the data. I mean, we can have a look at the data before visualizing that data. So we proceed to transforming the data. And still our tables are running. So we wait until that runs. This might take it might take quite some time, but let us give it some time, because in this case we are working with some tables containing more than around 50,000 values. That is why they may take some time loading. So some tables have some of the tables have actually finished loading. Okay, so now we have, I think we have our tables. We have our tables. We have our tables. So now we need to ensure that each column is correct. Each column has the right data type. That is what we are supposed to do. So we have to, so before that, I'm going to navigate to my view tab and then select on column quality. We need to see the quality of each column. We can also select on column profile, but before that, let us first of all work with column quality and column distribution. We need to see the distribution of values within each and every column. Know whether we have columns, maybe values which are unique, or columns which contain values which are not unique. So that is what we want to know.
All right, Musa, it's like your screen is frozen. Can you check?
Yeah, it's like, I think it might be. Let me see whether I can do away with some of them. Okay, I think I can do away with some of them. Do away with some of the applications. I mean, let me just minimize some of the applications that are running from the background. Okay, I hope now you're able to see. No, we can see it. So this is for the first table. Okay. So I think it's my network. If you can't see, I think it's my network. Let me change that to another one very fast.
Share your screen. We are just viewing the Excel workbook.
Okay. So are you able to see it right now? What about now? I changed the network.
No, sir.
Okay, let me stop sharing and reshare again. What about now?
Yes.
Good.
Someone says good. So I believe right now you are able to see my screen. So this is what I was talking about. This is what I was talking about. So now we have the different tables. We have the different tables on the left-hand side, and we also have the values for each and every column within each and every table. So like you'll be able to see each column and the distribution of values within that column. This is the distribution of values. Then the first part, we have valid, error, and empty. That one shows the quality of the column. So for example, in this case, when you see 100, that means that all the values are valid. We have no duplicates. If we are having duplicates, then you're going to be seeing some changes within the quality side within this region. You're going to see some changes. This is not going to be 100%. So like you can see for each column, we are having 100%. So the values are 100% valid for all the columns. And then you can also see the number of distinct values and the number of unique values per column. So you can see that. So we have some value, we have some columns which are having all the values being distinct and also all the values being unique. That is majorly the primary keys or the foreign keys for each and every specific table. The primary keys or even the foreign keys for most of these tables are having all the values being distinct and at the same time being unique. If maybe we click to the other table, let us confirm on the other table whether we are having the same. This is water source, and water source, you can see we are having this, it's still running. Yeah, we are having column 1, column 2. We have column 1, crime ID, time of incident. So we have all these columns, and this also has all the columns having 100% valid values. So we still don't see any duplicates in this case. And then we also need to confirm on the column headers. In this case, the column headers are crime ID, time of incident, location. So in this case, that is correct naming of columns. Then we move to the other table very fast. We just check on that. We check on that. So for this case, you can see the columns are correctly labeled. All the values are 100% valid. They are 100% valid. And you can also see the source ID column as all the values being distinct and at the same time being unique. Data types, you can see the data types. For example, for the first one, it's text. The second one is also text. The third one is their digits. Their digits, in this case, 1, 2, 3 represents digits, or even, yeah, in this case, they are just digits. So that is correct for the 3 columns. Then we move to the visits table. And this one is quite long. The visits table is actually having more than it's having more than 50,000 values. So we can also see that the columns are actually named well. The columns are correctly named. You can also see that we are having most of the columns are having 100%. The values are 100% valid. That means that we are not having, in most cases, we might be having duplicates. Like for this column, we are having duplicates. You can see that we only have 8 distinct values. So, and 0 is unique. So that means that we are having duplicates, but all the values are 100% valid. And yeah, that is it. Let us check on the data types. The record ID, that one has the right data type. Location ID, same. Source ID, that must be ABC, or even that is a text. Time of record, this one is a date time. That is where you can see something that has a clock. That is date time, correctly labeled. We also have visit count, 1, 2, 3, that is correct. So like this table has correct data types for each and every specific column. Then we proceed to queue composition. Queue composition. Queue composition. This is this is a table that shows the composition of people within the queues, whether the percentage of males, percentage of females, and the percentage of children in the queue for different maybe times when this data was collected or even this data was recorded. So we also have column 1. We have record ID, we have percentage male, we have percentage female, and percentage child. The columns are correctly labeled. What about the data types? The data types, you can see record ID, it's 1, 2, 3, that is digits. Percentage male, that is a float or even decimals. It's a decimal number, and as you can see, it's a decimal. Then percentage female, it's also a decimal, and percentage child is also a decimal. So that one is also correctly done. What about the distribution of values? You can see we are having 100%. Most of these values, some of them were repeated actually. Some of them were duplicated. But at the same time, we also have values being distinct, some values being distinct and others being unique. If you have unique values, that means that those ones are, or even when you say that something is unique, we say that there is nothing like that. There is nothing else that looks the same as that one. So in this case, we are having 733 values, and out of, we are having 733 values being distinct, and then we also have 546 values being unique. So that one seems to be okay. Then we have project progress. project progress. Now, as this one loads, we can check on the columns, the column headers. The columns seems to be okay. They are correctly done. What about the data types? The data types, project ID is 123, that is at digits, that is correct. Source type, address, town, province, source type, those ones, they seem to be correct. The data type seems to be okay. Then we have date of completion. Now, date of completion in this case is null, but it has been assigned 1, 2, 3. It has been assigned to 1, 2, 3. So, since we are talking about date of completion, I think this column should be, the data type there should be date time. Although this is a table that is going to be filled by the engineers, they're going to fill in the date when that work was completed. So we can change that. So you click on the data type and then you change that to date time. You change that to date time. Since that one is date of completion, then comments, it's a text. So that is okay. Then we move to location. Location, let us check on location and see what needs to be changed. Location, we can see we have column 1, we have column 2, column 3, column 4, column 5. So in this case, we can see that the columns are wrongly labeled. In this case, instead of using the column, instead of using location ID, address, province name, town, location type as the column headers, in this case, they are using a different type of headers. That is the columns, the different columns. So we need to ensure that we change this formatting. We need to change that. So what we are going to do, we navigate to transform. We navigate to not transform, but home, and then we click on, we use the first row, this row as now the column headers. So we are going to click on this option, use first row as headers, and it's going to give you two options, whether you want to use the first row as headers or use headers as first row. So in this case, we want to use first row as headers. So you click on that. And after clicking on that, you're going to see a change in the headers. So we have now location ID, address, province name, and location type. That is what we have in. So since we already have that, the data types are okay. The data types are okay. So you can see that all the values are valid across all the different columns. We are having some values being distinct, others being unique. But for example, in this case, you are having only one value being distinct. This is because like this table runs the first 1,000 rows. So within the first 1,000 rows, we are only having one value being distinct. But remember, the entire data set has more than 1,000 values. So if you save the changes, then the changes are going to, the entire table is going to be affected. And then we have this table. This table has correct headers for the different columns. It has correct headers for the different columns. And then we have only one value, 1% of the values is valid for the first column. And then for the second column, only 1% is valid. The other values are nulls. So we need to do away with these nulls. We need to do away with these nulls. So what we are going to do, we are going to select on where we have empty, and then we can remove the empty rows. We can remove the empty rows. And after removing the empty rows, you'll be able to see some changes within you. So now your values are 100% valid. They are 100% valid. And then you can see the number of values which are distinct and the number of values which are unique. You can see them. So that is it. That is it. So after you are now sure that your tables are good, or even they are in a good condition, you've done your cleaning and you're sure that they are in a good condition, you can now close and apply the changes. So on the Home tab, you click on Close and Apply Changes. And that is going to take some time.
All right, Musa, are you there? We can't hear you.
Just a minute. I think I was sharing a part of the screen. Just a minute.
That's fine.
Yeah.
Okay. While you're waiting, I want to ask a question. Yeah, this cleaning, we are doing it before we load the data, right?
Yes.
So what if you have loaded the data and then now want to do some cleaning after you have loaded it? Is it possible? Or
Yeah, it is still possible if you want to. Maybe you realize that there is maybe part of your data that was not correctly cleaned. You can still go back to your transform data set. I mean, transform the data and then you do your cleaning from there.
okay.
Yes.
All
Let me
right, that's
share
okay.
that. It's really taking long to load.
Yeah.
Okay, so I think that one is taking really long to load the data. Let me share another part of the screen. Okay. So I hope that you are able to see that. You are able to see that. That is another part of that is another. Let me call it a notebook, different from what we were using. So
You can see this.
So what I'm going to do in this case, since our data is already loaded, the next step is to check the relationships between the different tables. We want to see the relationships between the different tables. So after loading your data, you're not going to have something like, maybe you're going to have something like this, something that is almost similar to this. You're going to have something that looks similar to this, but some of the tables are not going to be connected. Let me just check whether that page has finished loading. Okay. So you're going to have something like this, but in this case, some of the tables are not going to be connected. They're not going to be connected. So, for example, if you look at this relationship, this is an entity relationship diagram that shows the relationship between the different tables within our data set. And as you can see, we are having different tables relating to other tables. And for example, in this case, you can see they have different cardinalities and also directionalities. For example, in this case, you can see we have a 1-to-1 relationship. In that case, that means that one value from the progress project table relates to only one value within the water source table. So we have a 1-to-1. We also have 1-to-many. We have 1-to-1, 1-to-many. That is for the infrastructure cost and project progress. And then we also have location, it's 1-to-many. And then for location and water source tables, they have a 1-to-many relationship. That means that one value from the locations table corresponds or even is related to, might have different records within the water source relations. That is water source relationship. I think it's water source related crimes. Yeah. So that is it. That is a relationship between the different tables. That is a relationship between the different tables. So now, since we have that, now let me just make this clear. This relationship, if you load your data, you're not going to have this relationship. Let me just delete this and maybe we just delete that. Yes. So you're not going to have this relationship here. That is for the water source and location. This thing is really taking a lot of time. Okay. So let's wait for that. I don't know whether it's my network that is really making this thing take a lot of time, but let us give it some time until it finishes loading. Okay, so this is what I was talking about. This is what I was talking about. The other one has finished loading. So this is what I was talking about. Let me just rearrange these tables. Let me rearrange these tables. So once you're done loading the data that we've just cleaned, you're going to have something like this. You're going to have these tables. You're going to have something that looks like this. Something that looks like this. So you're going to have the visits table, water table, we have locations table, and then we also have some more tables down here. Let me take them to one. Let me take them up so that we visualize them all together. Yeah, at least now they are somehow better. Yeah, so you're going to have something like this. You're going to have something like this. So if you look at this, let me take that there. There's another table here. Let me take this here. Okay, so this is what we are having. This is what we are having. Now, if you look at this, we have tables that are connected to one another, or even they are related to one another. And for example, between the visits and the water source table, we have a one-to-many relationship, and this is in one direction. The directionality is it's one directional. It's one direction in this case, from water source to visits. So that means that if you are filtering, this will only filter that data in this direction. That is from the water source and then towards the visits. So if maybe you want to filter data from visits then towards the water source, then this is not going to work out because the direction is specific. It's from water source to visits. And then the same applies to these two tables, visits and location. It is also one directional in this case, from location to visits. And it's a one-to-many relationship. And then for the queue composition and visit is one-to-one relationship. So that means it is bi-directional. That is, you can filter on any of the two sides. It's one-to-one relationship. And then project progress and infrastructure cost, it is also one-to-many relationship. And then for the water source and project progress, for water source and well pollution, the two are having a one-to-one relationship. That means that one value from this table is only related to a specific value within the well pollution, or even might only have only one specific row of maybe additional information about that specific value within this water source. So the relationship is one-to-one. And then we have water source related crimes and queue composition. So in this case, we are having one-to-one relationship. We are having a one-to-one relationship, and we need to check, like for this case, if you click on the relationship between the two tables, you're going to see the columns. You're going to see the columns. For example, the water source related crime table is related to queue composition because they are having the same columns. Like in this case, we have column one. So we need to check like whether those two columns are, you need to check whether those two columns contain the maybe relating information. And then I think we are going to do that later. So this is our representation of the different tables and how they relate to one another. So let me proceed. Let me not take a lot of time. So the second thing is to examine the model view of the relationship between the tables. And in this case, we notice that there are several one-to-one and one-to-many relationships, along with directional indicators for each of these connections. And then we are supposed to remove column one from the queue composition table and water source table. So we need to remove that column in that case. So if you look at this, I've said that the water source related crimes and the water composition, they are related because in that case, they are having column one, which is, or even it has the same values for the two tables. So I can say that maybe column one in that case serves as the primary key. So we need to remove column one from the two tables. So for us to be able to remove column one, we are going to select on that water source related crimes and delete column one. So what we do, we select column one, and then we right click on that and you see delete. So you click on delete and then yes. And that is done. So now column one is not there. So our first column is crime ID. We do the same to water source. We do this, not water source, that was queue composition. It was queue composition table. So we also delete column one. And now we are having record IDs as the first column. So we've done that. So like what we've done now is just additional cleaning of the data. We've realized that the, like in this case, the two columns from the two different tables had values. They were just numbers that were used for, to represent information that was collected from different regions in this case. So that is why we've done away with that. So we've removed column one from the two tables. Then we now need to ensure that the two tables are related. So if we now go back to our relationship, you notice that there is no connection between water source related crimes and queue composition. So we need to ensure that the two columns are related. Now, if you look at this, we are having, if you look at this, let me just open the two tables and let us look at the columns in each of the two tables. So for the first column, which is queue composition, we are having record ID. Record ID in that case. Record ID is, it contains distinct values for each and every record that was collected. So the record IDs in this case serves as the primary key. And then we also have water source related crimes. In this case, we are having crime ID. So if you look at this, crime ID and queue composition record ID, they are somehow different in this case. They are somehow different. They are somehow different. So we need to ensure that there is a connection between the two. So how are we going to do that? How are we going to do that? Now, for the water source related crimes, we are having crime ID and location ID. We are having crime ID and the location ID. So if, for example, if I try joining this table to this table using maybe the record ID and the location ID, then I may end up getting maybe wrong values, or even maybe, yeah, I may end up getting wrong values. But let us try that and see what is going to happen. So we can just click on that and take it there. And you can see we are having location ID, which is different from record ID. The location ID is very, very different from record ID. If I was to select crime ID from the first table, you can also see that the crime IDs are very, very different from the record ID. So that means that if we connect them on these two columns, then we are going to have values which we are not going to have maybe wrong visualizations, because we've connected the two tables on columns which are not related in this case. So we cancel that. Now, what about if we connect the water source related crimes and the visits? Since the two of them are having location ID, we are having location ID in both tables. For this one is log ID, which represents location ID. And then we also having location ID within the visits table. Let us try that and see what is going to happen. You can see the location IDs are similar in this case. They are similar. They are the same location IDs, but we are having a warning here. The relationship has cardinality many to many. So in that case, if we are to connect that, then we would come up with many to many cardinality. And from your previous presentations, I know you must have heard that anytime you are working with data that, tables that contain many to many type of cardinality, then it will be very, very hard for you to carry out maybe visualizations or even aggregations, because there will be a challenge in this case, because that means that one value within the first table has very, very many values that are related to the same value within a different table, and the same with the second table. This value here, this location ID here might have several entities within the first table. That is what it means. So it will be very, very hard for, assume you are doing aggregations, it will be very, very hard for Power BI to determine which value you want to aggregate, because you're going to have the same location ID, but having so many entities within the first table. And then the same will also happen within the first table. Same location ID, but now so many entities, or even so many rows containing values for that specific location ID within the second table. So in this case, we are not going to connect the two tables using these cardinality, that is many to many. So we look for another one. So we can connect these two tables, this one and this one, using the locations table. Since the locations table has location ID, so we can connect this using the location IDs. And in this case, you can see we are having a single filter direction, and then the cardinality is many to one. Many to one. That means that one value within the locations table will have various entities within the crimes table. So we can connect that. Since it's a many to one, we can just save that. We can save that. And after saving that, we now have this. It's one to many or many to one cardinality. So now we've connected this table and this one. So if we want maybe to filter information, or even we want to use these two tables, queue composition and water source related table, remember there is a linkage between the two tables. water source is connected to location, location is connected to visits, and visits table is connected to queue composition. So in this case, if we want to filter information from water source, then location, then visits, then queue, then we are going to change the direction in this case. We are going to alter the direction because in this case, the direction is from locations to water source related crimes. So we are going to change that. So that is what we have. And then many of the relationships in our data model are bidirectional filtering, but most of them are one-to-one relationships, which is perfectly fine. So anytime you are having one-to-one or one-to-many, that would be perfectly fine as long as you're working with one directional, you're working with data that is filtered in one direction in this case. So make sure that all one-to-many relationships have single directional filtering enabled. So we are not going to enable the double or even bi-directional filtering. And then we check the data types to ensure that they are the right data types. We've already checked that. So visits is our fact table in this case because it recorded thousands of inspections of water sources across Maji Ndogo. So if we are to look at this, almost each and every table is connected to the visits table. Almost each and every table is connected or even it's linked to the visits table. Now, the visits table has 3 keys. We have location ID, record ID, and source ID, which they serve as foreign keys in the different tables. For example, we have location ID within the locations table. We also have location ID within the water source related crimes. We also have record ID, which is also found in the visits table. We have source ID for the well pollution table, source ID for the water source table, and then for the infrastructure, they are using a key termed as improvement. In that case, it's improvement column, which is being used to link the 2 tables. So in this case, the only 2 tables that do not have their source within the visits table, it's infrastructure cost and project progress in that case. So we would term our visits table as our, we would term it as our central table. We would term it as our central table in this case, or even our fact table. You remember the star method in this case, the visits table is going to be our fact table, and then the other ones are going to be maybe the branch tables. They are dependent on the central table. So water source related crime links crimes from the past 10 years to a source location, which is unrelated to visits. So this complex relationship prevents us from making a simple star schema, and therefore our model is a multi-star schema. Why are we saying that our model is a multi-star schema? In this case, because we are having the visits table linked to all these other stars or even star tables in this case. And then we are having project progress serving as its own fact table and infrastructure cost serving as its own fact table. So in this case, we are going to have different tables serving as fact tables. So that is why we are calling it a multi-star schema. I mean, the model is a multi-star schema in that case. So we are done with the first part. So let us now navigate to our second part, which is on visualization. And in this case, we want to create a national page and add the following visuals. So we are going to create a national page and add all these visuals. So we add a page, and then maybe we can name that national. We name that national. And then we are going to add, number 1, we are going to add map of provinces in Maji Ndogo. That is what we want. We want a map of all the provinces in Maji Ndogo. Now you remember from our previous analysis, or even from our previous visualizations, we were able to come up with a map of all the provinces in Maji Ndogo. So that means that I'm going to need the provinces, all the provinces. So I think all the provinces are found within the locations table. So I'm going to select on province name, and then that would be a table. I need to see all the provinces within the locations table. Yeah, you can now see all the different provinces. These are the different provinces. Now, the next thing is to visualize them. And in this case, we are going to select on a shape map because we don't have Maji Ndogo within our, or even the map of Maji Ndogo is not a known map. So in this case, it's going to be a shape map. And then we select it from our previous downloads. We had downloaded that earlier. That is during our previous discussion. So we pick that. It's a JSON file, and then we also need to, this is what we are having. This is what we are having. So you are going to have something like this, and then we can now use our previous image that contained all the values. We can actually insert that. It was an image. We can insert that as the background. So we insert image, and then it was a map of Maji Ndogo containing all the provinces. And this is what you are having. So we need to send this to the background. But before that, we need to remove the background of our map. So we need to ensure that the background is turned off so that the two can actually, so that we can see the map. So let me take this to somewhere. So now we have this. And as you can see, you are having all the provinces having the same color. So you can use different colors. Maybe you can change the default color if you want to change that. But for my case, I want to change the color for the different countries. So you can navigate to, let me see, should be somewhere. We've used province name as, we can also add province name as the legend. And still after adding province name as the legend, the color remains. So we need to change that from our settings. We have so many settings here. Can turn that off, that on. I can't seem to see that option. Label color, okay. I don't know what I'm missing on that. So in this case, you are going to have this. This is just it is just a map of Maji Ndogo with all the different countries. So in this case, if you want each country to have its own its own color, then you need to move to the format option, and then you'll be able to see an option for you to change the colors. Let me see this. No, I don't need that. Yeah, that is what I was looking for. So for Amansi, we are having this. Okay. So now let's check on this. You'll be able to see a setting. You'll be able to see a setting for each and every. You'll be able to see a setting that allows you to change the colors for each and every country. So okay, so immediately you are done with that, you now need to take this. You need to take this such that the two are overlapping, but in this case, you have to ensure that they match. So you have that. You have that. The next thing is to take that to the background. We need to take that to the background. So so right now you are having that. So let me just, I think there is somewhere where I'm missing out on that. Let me remove this legend. And then let me now go back to this, fill colors. Yeah, this is what I was looking for. Actually, it's this icon here. You click on show all, and then you'll be able to change the colors for each and every specific country. So for Katsi, it can be that. For Amansi, you can choose maybe a different color. For Awasa, you can choose a different color. And then for Kilimani, you can choose maybe that. Then for Sokoto, you can choose maybe green. You can choose green. You can choose green. Yeah, so this is what we have. This is what we have. So we've already represented the countries. We've already represented the countries. So the next thing, we need to ensure that this is not moving. So you click Control All and then group. You click on group them, and then you can now take these to. Okay, I think I did that before taking one of the pictures to the background. Sorry about that. So let me take that to the background. We format that, and then we send it to the background. So send it backward. Yeah, and then now we Control All, and then group. Yeah, and then now you can minimize that. So now these are representation of the different countries, and they are the different, the different provinces, not countries, sorry. the different provinces. So we are done with that first part. So the next part, we need to come up with a pie or a donut chart of the population split between urban and rural areas. So the split between urban and rural areas. So for that case, that means that we are going to need the location type. So we drag location type there, and we only have two. And then we also need population. Population is people. That should be found within the water source table. So we click on number of people served. Number of people served. And in this case, we need the total. So we are going to aggregate that by sum. And let me open this, and then we change that to a pie chart. And this is what you're seeing. In this case, after visualizing this, you can see we are having rural having 28 million and urban having 28 million. Remember our total population. Let me first of all calculate the total population in Maji Ndogo. Let me calculate the total population in Maji Ndogo. The sum of people in Maji Ndogo. So if you look at this, the total number of people in Maji Ndogo, they are 28 million. 28 million. And then we ask ourselves a question, why are we having urban having 28 million people and rural having 28 million people? In that case, that means that there is a problem with our tables or even our filtering. There is a problem with our filtering. So we navigate back to our relationships table and we check on our filtering. We are using the water source table, which is this, and the locations table. And if you look at this, we've picked, the first thing to pick was province name. That was the first thing, province name. And then we went to the water source table and aggregated the number of people by location. Sorry, it was not province name, it was location type, sorry. So we, first of all, picked this column that contains the different types of locations, whether urban or rural. And then we were able to aggregate the values, that is the number of people that are served in that case. So from locations to visits, it's one to many in that direction. And then from visits to water source, it is many to one. I mean, one to many, but in the opposite direction in this case. So we need to ensure that we activate our bidirectional filtering for that to work. I mean, for the aggregation to work. So you click on this, and then properties, and then we change that. We change the cross filter direction to both. That is one way of doing that. Okay, let us wait for that. I don't know why it's really taking a lot of time to just change that. I think my system is really, my system might be really down, or maybe my network, but anyway. Okay, let me cancel that and maybe do it again. It's really taking a lot of time. Okay, I can see it's already activated. It's already activated. I think that went through. So now we need to navigate back to our visualizations and see whether there are any changes. So as you can see, there are now some changes. We can see that we now have some changes. We now have some changes. Right now, you are having 18 million for the rural population and 10 million for the urban population. You can also use a donut. You can use a donut. A donut is this one. looks like a donut actually. So it will still serve the same purpose. Now, on the part of coming up with clear titles, you can change that on the format your visual. You move to, in this case, you can click on the general and you'll be able to change the title. For example, in this case, I can change that to population by location. That we know that is total population by the location, whether it's urban or rural. And then I can maybe take that to center, that is center alignment, and then I can change that to red, or even maybe a different color. Yeah. So that is it. That is it. You can actually modify, you can actually change the colors depending on what you like most. So this is it. This is it. Now, that was one way of doing it. You can change the direction of filtering, or you can also join the tables, right? Like in this case, we want information from the locations table or the water source table. So we can also join the tables. So what we do, we move to transform. So in this case, we are having our locations table. This is our locations table. Let me just turn off let me turn off this, just a minute. I need to turn off the views, the column distribution, the column quality, but it doesn't keep on, yeah. So we need to join the locations table and the water source table. That is what we want. Now in Power BI, if you want to join any two tables based on a shared column, then you navigate to the home tab, and then you will see somewhere written merged queries, and then append queries. In that case, append queries. So for my case, I want to join two tables. And the two tables, if I take you back to the relationships, you realized we had the locations table on the right and the water source on the left. And then in between them was visits table. We had the visits table. So the visits table serves as our fact table. So in this case, since it is our fact table, we are going to click on the visits table. Remember, it has the location ID, the record ID, the source ID. Those are different primary keys in different tables. So we are going to click on that, and then we click on merge queries. Now, there's a difference between merging. In Power BI,
sorry, Musa, we're not seeing your screen. Your screen is hanging.
Okay, let me see whether I can refresh that. Let me see whether I can refresh that. What about now? Are you able to see anything?
Okay, if you just move your mouse around, yeah, good, we can see it now.
Okay, so let me take you back to the relationships. What I had done previously was changing the direction of filtering. I enabled bi-directional filtering, or even filtering in both ways. So maybe I can take these, I can maybe revert that to what we had before, and then apply single, and then maybe we can now use, maybe we can join the two tables and see whether there is going to be any changes between the two.
Okay, I have a question while we are doing that. You know, on these relationships now, if at the start, before you even start working with your data, and you have some one directional, this thing, and you decide to just change all of them to both directions, you know, so that when you're working on your data, you don't, maybe you may not encounter this. What could be the risk or the challenges? And then the ones that I want to, yeah, I think that should be it. What if we just decided, looked through the data and decided to make it be both sides instead of just one direction? What could be the risk, or could it affect our data per se?
Well, what I will say about that is that if you're having a one-to-one cardinality or even relationship one-to-one, then that would not be like, it won't be a big deal when filtering data, because that means that one value in this table is related to one value from the other table. But if you're having one value here and you want maybe to get, maybe you have one value from the locations table, and maybe you want to get or even to filter values from the visits table in this case, that is a one-to-many relationship. And the direction in this case is in the, maybe let me say it's in the left side. It's towards the left side. So for that case, it's going to work. What about if I have, remember within the visits table, I have different records having the same location ID. Like for this locations table, I'm having one location ID, and that location ID is having different entities. Like take an example, if this was a location like maybe Bello, a location like Bello might have multiple records within the visits table. So if I want to aggregate, I want to know the aggregated values for Bello from the visits table, then it will be easier for me because the direction, I mean, it's one directional in this case. But what about if it was bidirectional and I want to get the aggregate records for Bello? In this case, Power BI won't be able to recognize, because remember from the visits table, we are having multiple records of Bello and only one value for location. That is one ID for location. So it might be somehow tricky knowing which direction to follow. Yeah, that is why we majorly use one direction when you're working around with the relationship between two tables. But if you realize that maybe the values that you are getting are wrong, or maybe you need to filter in another direction, you can change the direction. Actually, it's actually something that is very, very simple. Now, if you think, if you feel that is hard, you can also join the tables, like what I was saying. You can join the tables, and for you to be able to join the tables, you need to identify the stars table or even the fact table. In this case, the fact table is visits. So I want to join visits table, location table, and water source table, the three, so that I can have all those values within the same table, and then it will be easier for me to work around with all those values.
And please, I was asking. Please, I was asking. How are you sure that this is the fact table and not the other kinds of table?
Okay, that is a good question. How am I sure that this is the fact table? Now, for this case, I am having three tables. I'm having three tables in this case. Like I want to get information from the locations table and the water source table. So what connects the two tables? Now, for the locations table, we have the location ID, which is common, which is also found within the visits table. And then I have source ID for the water source table, which is also found within the visits table. So in that case, these keys are found in the other tables. For this case, you can see the visits as three keys: location ID, record ID, and source ID. And these serve as maybe primary keys in other tables. So like all these other tables are connected, or even they have values which are found within the visits table. Like these three keys are found within the other tables. So in this case, it serves as my, or even I can see that it is a table at the center of my star, the other stars. So within my star schema, this is the table that is in between. Now, for project progress and infrastructure cost, I said these ones are having different other maybe primary keys. Like improvement in this case is the one that is linking project in progress. It is the one that is linking. In this case, if you click on this, you'll be able to see improvement is the column that is linking the two. So that means that it might be the primary key in that specific table. So for this case, if the visits table also had improvement column in that table, then we would say that all these other tables are, they are stars. Let me call them stars, or even let me call them branches. They are branch tables. And then this is the mother table. I think that that makes sense.
So the mother table is the fact table.
Yeah, the fact table. It is a fact table in this case.
And if that is so, then there's something I was trying to read, and then I found something like a branching table, something like that. Branching table. What is it? What is the branching? I think it was something like branching table.
Okay, a branching table. Maybe if I'm not sure whether I'm going to. Maybe it might have been used in a different context. But in this case, a branch table is like a child table. Let me say it's like a child table. So this one, if I wanted to get information about, maybe some information about locations, I would find some of that information from the visits table. If I also wanted to get some information about water source, I will get some of that information from the visits. Since all these sources, all these tables, they have primary keys that are found within the visits table. So like all of them can be connected together. And in this case, the central table will be the visits because it has these 3 different keys. So if I'm to maybe answer your question, I would say that a branch table is just like a child table. Like a table connected to the mother table, even the fact table.
Okay.
Yes. So how do we connect the 3? We want to get values. If you look at our visualization, we right now have changed the direction to only single direction in that case. And you can see the aggregated values are 28 million for the rural and 28 million for the urban. But in this case, I only want values. I only want the aggregate for the 2 locations. I don't want for the national population. I want for the rural. So what am I going to do? So we go to our data, and then transform data. We click on transform data. And in this case, visits table is my fact table. So, and if you look at the visits table, I think in this case, that is from your SQL, you also noted that visits table are the highest number of records. So we want to keep everything from this visits table, and then maybe add values, add maybe any matches from the other tables. And in this case, all the values are going to match since the primary keys in both the water source table and locations table are also found within the visits table. So all the values are also going to match in this case. So I want to join them. So joining queries in Power BI is the same as, okay, what have I said? Merging queries in Power BI is the same as joins. So when you click on merge queries, it's going to give you an option whether to left join, whether to maybe right join, whether to do an inner join. You're going to see all the options. Then if you want to maybe a union, maybe you want to union, maybe intersect, maybe minus, or maybe, yeah. If you want to do any types of unions, in that case, union all, then you use append queries. So append queries in this case serves the same purpose as union all. You'll be able to see all those maybe options, and you'll be able to choose the one that you want. So for my case, I'm going to choose merge queries. This is the one that I want to use. It serves the same purpose as doing it. Okay, are you seeing anything at all?
Yes, we are seeing the pie charts and the map.
You're seeing the pie chart and the map. Let me share the entire screen then. I think that was just a pop-up. Let me share the entire screen.
Yeah, I think that would be better.
What about now?
Yes.
Okay. So now, this is what I was talking about. So we are having the tables on the left and all the values on the right. So in this case, we want to join the different tables on a specific condition. the condition is that the primary keys must match, or even the different columns that are related within the two tables must match. That is the condition. So we proceed to match queries. This is what I was talking about. Margin queries is the same as, or even it gives you the 4 different options: join, that is left join, right join, inner join, and full outer join. And then for appending queries, this gives you the different options like union, union all, except, and minus in that case. So we are going to use match queries. And then we are going to select on merge queries. Okay. So after selecting on merge queries, we need to select the next table. So you're going to see a drop down, and this drop down is going to give you it's going to give you the different tables that you have. So let me select on water source, and then the next thing we need to select on the keys, or even the condition that we are using to join our tables. Just like in SQL, you talked about the condition in that case, whereby specific columns are to be related. So for this case, we are going to use the source ID. The source ID from the first table must be related to the source ID within the second table. And if there is a connection between the two, you're going to see a small tick down here. Estimating matches based on data previews, you're going to see a tick. So that means that you can see the selection match is 60,146 out of 60,146. So like I said, we are having all the values matching the values within the first table. Then the next thing, we need to choose on the type of join that we want to use. What type of join do we want to use? In this case, I want to preserve everything from the visits table. So that means that I'm going to use a left join. I'm going to use a left join or even a left outer join. And in this case, we have left outer join, right outer join, and very many others. So we are only going to use this. We're only going to use this, the first one, a left join, and then you click on OK. After clicking on OK, you're going to see this. You're going to see this. Now, these are the values from the second table. You're going to see water source table, and there's an option to expand. So you click on that option, and it's going to give you an option. So do you want to expand or aggregate? In our case, we don't want to aggregate, we want to expand. So we click on OK. And after clicking on OK, you're going to see all the values from the water source. So they are going to be labeled water source.source ID, water source.type of water source number of people served. So now we've connected the two tables. Since we've already connected the two tables, the next thing, we need to add our third table. Is someone trying to say something? Okay. So we now proceed again to margin queries. And then in this case, we are going to add the locations table. So we choose on the locations table. And at the same time, we want to preserve everything from the left. So we have location ID. That is the column that we want to use in joining the two tables. And then we wait until we see whether there are any matches within the two tables. And we can see that all the rows are actually matching. 60,146 rows are matching. At the same time, we also use a left outer join. Then we click on OK, and you're going to see the same thing that happened with the first one. So you're going to see locations table. So you click on this small icon over here, and then you expand the values. Really taking a lot of time. Just give it some time. So you'll be able to see all the applied steps from the left side. So our table is already joined. Now we have the locations table, location ID, address, province name, town name. So we are now done with this. We are now done with joining the three tables. So we've now joined them. Remember, we've not created a new table. We are only working with the old table. So we click on close and apply. Close and apply. And after clicking on close and apply, remember what we had here, we had values from three different tables. So now we need to select those values from, that specific table that we've just come up with. We need to click on that. That is what we need to do. And actually, that is what had been done for the first table that we were working with. They had actually joined all the, I think there are 7 tables. They had joined them into a single table, and we were able to work around with that easily. So you can also do the same, but for the purposes of checking the relationships, we need all these tables. So let us wait until this finishes loading. I think the size was really big. Okay. So now we are done with that. So we can, I can cancel that. So now let me do something else here. Let me now open the visits table and then we check. As you can see from the visits table, we have lots of values. We have lots of values. We have very many values. So we can select the, just drag this a bit. So we can select the location type, and then after selecting on that, the next thing we can select on the water source, number of people served. Water source, number of people served. And we need to filter. In this case, you can see we are having 48 million people. So we need to filter such that we are only going to have values for the first visit count. That is what we are going to have. So we add visit count to the filters tab, and we only include values for the first. We only include values for the first visit. Yeah. So now let us visualize that using a pie chart. And I think this is somehow better. So now we are having this. So if you compare this and the old one, you can see the differences. You can see the differences between the two visualizations. The first one we had no, like there was a relationship, but the relationship was one directional. It was single directional. But for the second one, we've just linked the two tables, and then we've been able to find the aggregated values for the number of people living in the urban and the rural areas. So that is it. Now, assume you've joined the two tables and you don't want to maybe work around with that table. Maybe you don't need it anymore. So you do the same, you proceed, you navigate to the transform data, and then you'll be able to undo the changes. So yeah, so we click on the visits and you'll be able to see all the changes. So these are the changes that we made to our table. So you can just click on each one of them and it will undo the changes. It will undo the changes. And I believe now we have our visits table the way it was. Then we close and apply. Okay. So now you're going to see an error because we've changed our visits. So that was just a way, it was just by the way, to show you that we have various options that we can use. So now let me just change my direction to bi-directional properties, and then we change that to both, the cross filter direction to both. Yeah, and after doing that, you'll be able to see changes within your data. Now you can see changes. So we now have that. We now have this. So let us proceed to our next visualization. Let me just minimize this for the purposes of space.
Excuse me, Moses, but
yes,
I was just wondering why you had to change the single into a both right now.
Oh, the reason as to why we've changed the single directional filtering to both. In this case, yeah. It's because we were retrieving information from this specific table, and it was the relationship was one to many, the cardinality was one to many, and the direction was from water source to visits. So like it was the opposite. What we wanted was the opposite of that filtering. Like we wanted to get information from location, and then we now get information from water source. So we are moving in this direction, that is from locations to water source. And what we had was water source to visits. So it was the opposite. We had to change the direction to both so that we accommodate for, that is for filtering on both ends.
So does it mean that that the relationship that we can only query on the direction of the arrow and not against it?
Yeah, for example, for this case, let me get another one where we are having a single. Now, for example, infrastructure cost and project progress. This means that we only have one record within the infrastructure cost related to many records within the project progress. So in that case, the direction that we can filter our data is from infrastructure towards the project progress. Otherwise, if we want to get maybe values from the infrastructure cost and we want to filter from project progress to infrastructure cost, then we are going to get errors or even maybe wrong results because it's in the opposite direction. In this case, the filtering should only go or even should only follow this direction. That is infrastructure cost to project progress, not the other way around. So if we want to get information from this table and what we are having is this table, then we have to change the direction, in this case, the direction of filtering to both.
And yeah, I've understood that. And does it mean that the only way to bypass that problem is to create joins? The only way to
that is not the only way. I've actually showed you two ways. So the first one is by changing the direction of filtering, and the second one is now joining the tables. You can join, like for me, I can join all these tables as long as they are having information that is related. I can join all these tables. The only one that I can't join is improvement and project program. I can't join these two to these other tables, because in this case, they are using a different key which is not found within my central fact table. So these two are serving as different fact tables. That is why I can't join them to these specific tables. But at the same time, they are also related. Like for this case, you have the project ID, no, not project, but source ID. source ID is related to water source. So actually, if you work around with these tables, starting with the visits table, you'll be able to join all these tables, all of them, into a single table, as long as they are related to one another. So you can do that, you can join them, or you can change the direction of filtering to accommodate both. But where you are having one-to-many relationship, in that case, it's always advisable to use single filtering, not unless maybe you need to use it. Maybe the double, you can use the bi-directional filtering.
Okay, thank you.
Okay, so let me check where we are. So I believe that one is okay for all of you. So the next step, we are to okay, yeah, I'll take you back to this. So the next step, we are to come up with a tree map of the total number of people per source type, the total number of people per source type. So we need the source of water, that is source type, and then we also need the total number of people. That is what we need. So we come up with number of people, that is, where is that? Number of people served, and then we have source type. So source type, in that case, it is the source of water. So we are going to select on type of water source. And you can see we have different types of water sources. And then we now select on the total number of people served. Let me expand this. Okay. And then we change that to aggregate the values. In this case, we need to aggregate the values. So number of people, we change that to sum, the aggregation method to sum. And after you've done that, remember the total number of people served must be around roughly 28 million. That is approximately 28 million. So this is what we are having. So we come up with a tree map. So we change that visualization to a tree map. And this is what you are going to have. Let me just take this somewhere here. Let me take it somewhere there. Yeah. So we were supposed to create a visualization or even a tree map showing the total number of people served by each source of water. And we've already done that. So this is it. Now we can also include a filter. In this case, we can include a filter whereby visit count is 1. Let us add a filter and see how our data is going to change. Let's see how our data is going to change. So our filter is already applied, and there is no change in our data. Actually, there is no change in our data. As you can see, there is no change in our data. The values remain the same. The values remain the same. Okay. So that is it. So you can see the shared tab takes the highest. It takes the highest. So if we want to know the number of people on a national level who are living in rural parts of Maji Ndogo, and they are also sharing a tab, then we just click on the shared tab, and then you'll be able to see the changes within the population by location. And then if you want to know the distribution of people for the different provinces, we can click on the province name, that is Kilimani, and you'll be able to see the change. You'll be able to see the change in this value. Let me see. Yeah, that is what I was looking for. So this is what you are going to have. If you click on the different provinces, you'll be able to see a change in the values depending on the number of people who are using the different types of water sources. Okay. To our next visualization, we are supposed to come up with a column chart that counts the different sources by location type. So a column chart counting the different sources by location type. So sources of water counted by location type. So we need location type. We need location type. That is the first thing that we need. And then we need sources of water. We need sources of water. And then we need them counted. We need another column for count. We count the location type. I mean, we count the sources of water by location. So in this case, for that column, we are going to use count. Yeah, and you'll be able to see these values. You'll be able to see these values. So we've been told to create a column chart. A column chart. So we can use any, but for this case, okay, let me use the first one and maybe change them and see. So for this is a stacked column chart. This is a stacked column chart showing the rural, the urban, and it is showing the number of water sources, or even the number of source types that we are having in that case. The number of source types. If it's a river, how many rivers do we have in the rural region? This is a start. You can also change that maybe to, we don't want us, we want maybe a clustered won't be better, but maybe we can also use a clustered column chart. And a clustered column chart gives you something that looks like this. In this case, it will be better for visualization. You'll be able to see that rural has the highest number of wells, followed by, then in that case, in rural areas, the second one is a shared tap. And then in both rural and urban, you can see the number of rivers are less, they are few. They are very, very few. That is for both rural and urban. So you can use any column chart that you find most, maybe you find better, you can use any. So for my case, let me just use this. And then maybe you can change your legend to appear on these values to appear on the left. So we can proceed to legend, and then the values, we keep them to the right, not left. Center right. And yeah, you'll be able to have this. You'll be able to see something like this. Let me just drag this down. You'll be able to see something like this. Okay, so that is it. That is the distribution, the count. This is the count of the different types of water sources for the different locations. And then the next in line, we are supposed to come up with a column chart showing the total number of each source of water type for every town. So now we need every town. We need every town. So the first thing we are going to come up with, or even we are going to select on the town name from the locations table, town name, and after selecting the town name, you'll be able to see all the towns. You'll be able to see all the towns. Let me change that to a table. It's given me a map. So we have the different towns within Maji Ndogo. These are the towns. And then the next thing we need to know, the total number of each source type, the total number of each source type in that case. Each source type, or even each water source type per location. So the next thing, we add the source of water. We add the source of water. We add the source of water. Type of water source, yeah. We add that. So you now realize that for each town, we are having 5 records. 5 records. That is for the 5 sources of water. And then the next thing, we need to count them. We need to know how many sources do we have per town? How many sources? So we add another column for count of type of water source. Count type of water source. You just add that and then change this to count. Okay, just check on that. Okay, so let me begin with, I can see that one is not giving me the option to, let me just start with count first of all, and then count. Yeah, count is there. And then we add town name. We can take town name above count. And then we add another column, water source, type of water source. So now we have this. We have this. I can also take count just below. We have this. So the next step is to visualize. Let me just make this broad. So this is what we are having. We have town name, type of water source, and count of type of water source. We can shorten these names. We just double click on that, and then we shorten them. Like that can be count, and then this one can be water source. The names are really long, so we need to make them short. Yeah, they are now better. So let us now visualize that. We are supposed to use a column chart. So we click on any of the column charts, and then we check which one represents the data in a better way. Now, if you look at this representation or even visualization, you can see rural as the highest number of wells. It has the highest number of wells in this case. This is by town. Rural has the highest number of wells. So since the values are really big for the rural, or even you can see that the number of wells, number of taps, number of rivers in rural parts, they are really, really big. And in this case, I think we are accounting for all the towns that are found in rural parts of Maji Ndogo. So this one seems to be an outlier. So we need to filter our data to only contain values. These are the values, because this one seems to be an outlier, or even maybe it's accounting for all the towns found in rural parts of Maji Ndogo. So we filter that. So we use town name, or even maybe in this case, we click on the drop down and you're going to see all the towns. So we select all, and then we ignore rural. We only use values whereby, I mean, for those other towns apart from rural. And then that is what we have. So after now filtering, you can see we are having all these values for rural. These are the values for rural. So I don't know whether this is going to fit, but let me just have it there. Okay, so that is what we have. Now, remember when we were talking about the sum of number of people served by the type of water source, in this case, we were able to identify the total number of people served for each and every specific water source. So if you look at this other visualization here, it's having, it's the count of water source per location type. So we also need to introduce a filter in this case. We can use a filter, or we can delete the values for rural from our data set. we can delete the values for that. But in this case, we are just going to use a filter to filter out the values for rural. So for this specific visualization, we also use values whereby the town name is not rural, and see how our data is going to change. And if you do away with rural, then you're going to have only one visualization, or even only one column in this case for urban. So what does that tell us? That the values for rural that we were having here, the values for rural that we were having here, they were values representing the location, representing all the towns which are found in rural parts of Maji Ndogo. And that is why you are having a very, very big column. That is why you are having a very, very big column. So that means that our visualization is correct. It is correct. So now we can do that. We can just click the rural again, and we have our data for rural. We have our data for rural. So these are the visualizations. These are the visualizations. So what do we learn from this? With these visualizations, we can be able to determine, like we can be able to know which towns are found in maybe Kilimani. For example, if I want to know the towns that are found in Kilimani, I will just click on that region, Kilimani. And if you click on the town Kilimani, you'll see a change within this visualization here. Let us wait until that runs. Okay, yeah, I hope now we have it. So you can see the different towns like Harare, Mrembo, Isikalo, Zuri, and Amara. Those are the towns that are found in Kilimani. So out of these towns, which one has the highest maybe percentage of, it has the highest percentage of sources of water? It is Harare. It has the highest. It has the highest. And then if maybe we wanted to know the towns that are found in Sokoto, you just click on Sokoto. And at the same time, you're also going to see a change within all these visualizations. So Sokoto, let us wait until that runs. I think my system today is really down, really taking a lot of time. Okay. These two are still loading. Okay, let me just refresh that and click on that again. Yeah, so we've clicked on Sokoto, and you can see the towns that are found in Sokoto: Ilanga, Majengo, Kofi, Bahari, Marang, and Cheche. So out of these towns, which one has the highest percentage of water sources? It is Ilanga. If I wanted to know the one with the highest percentage of maybe this blue represents what? Okay, let me assume we were talking about, let me just expand this. I think I'm going to change that later. So assume I wanted to know the one with the highest percentage of wells. The blue represents wells. So the one with the highest percentage of wells. So I'm going to click on Sokoto. We click on Sokoto. We click on Sokoto. That is the control, and then click on Sokoto and click on wells. On the second visualization, we click on wells. And after clicking on wells, you're only going to see data for the wells. So now we have Sokoto, wells. So on a national level, how many people in Sokoto are using wells? I mean, how many people in Sokoto are using wells? So those that are using wells on a national level, we have 1.31% being in urban, and then 0 million, I think that was, let me expand this, 1.81 being in rural. 1.81 being in rural. What about in towns? Which town has the highest percentage of wells? The highest percentage of wells in Sokoto. So if you compare these columns, you'll be able to note that Ilanga has the highest percentage of wells. It has the highest percentage of wells in this case. 322, this one has 250. What about if we wanted something else? And apart from that, you can also see that the population of people using wells in Sokoto is 859,000. That is from our national value here. It's 859,000. The percentage of people, I mean not percentage, but the number of people in Sokoto using wells, they are 859,000. Let us maybe click on something else. Assume we want to know the number of water types, the number of water sources in this specific region here, which is Hawassa. So we click on Hawassa, and let us assume that we only want the people living in urban centers in Hawassa, and at the same time they are having broken taps. People in Hawassa living in urban areas and having broken taps. Assume that is what we want to know. That is what we want to visualize. So what we do, we just click on Hawassa. We click on the control key and then click on Hawassa, then click on urban. In this case, urban is this one. You click on urban and then you click on tap in home broken, and you'll be able to see everything. So for that case, the number of people living in Hawassa, in the urban parts of Hawassa, whose taps are broken are 217,000 people. 217,000 people.
Sorry, I was just asking. So while you are doing the clicking, is it a must to continue pressing control?
No, you just control, and then you click all the parts that you want. Or you can also use the shift key.
Okay.
Yeah, you just press on the control key down and then you click. Like for this case, I will just press control and then click on Hawassa. Then I can click on rural if I'm interested in rural, and then tap in home broken. And it will give me values for the people who are living in rural parts of Hawassa whose taps are broken. There are 354,000 people. And then you'll also be able to see, like this is now the count of broken taps. The count of broken taps is 2885 on the rural parts of Hawassa. On the rural parts of Hawassa, that is what you are having. That is what you are having. I think in this case, on the towns, I think we do not have towns in rural parts of Hawassa. That is why the town visualization in this case is it's not having any highlights. It's because maybe we don't have any values, any towns within the urban parts of Hawassa. Not urban, but rural parts of Hawassa. Okay, I think we are done with that. So from our visualization, what can we say about that? What can we say about that? So in this case, we are told to discuss the interdependence of these visuals. So that is what we've just done. We've discussed the interdependence of these three visuals. So the next thing is to, yes?
Sorry, Nini, I was just asking, while you are adding the columns to the visualization pane, I saw that for the last visualization and even for the others, there's a specific order by which you are adding the columns. For example, I saw as if your count of type of water first, water source, you had to rearrange the columns in the table as you are. Does that really have a significance on the analysis, on how easy it is making the visualization?
Okay, so I think yes, it might, in one way or another, it might help, because anytime you are visualizing anything, you need to know what should come first and what should not. What should follow. For example, in this case, we are told create a column chart showing the total number of people, not number of people, but number of each source of water for every town. So you can decide to filter your data to only output the values, to only output the different towns within your region. You can start with towns. Then after that, you now find the sum of the number of water types. But before that, you need to come up with a column showing you the different water types that you have, because you need to know how many water types do we have in Maji Ndogo, how many water types water source types do we have. So you need to have a column for that. And then what should follow is now the count of these water types. And then after that, after you are now sure that everything is correct, you can now visualize that. Otherwise, you can also decide to start with the source of water type. It will give you 5. And then from there, you now add the town column. Each town is going to have the 5 sources of water if they are there in those towns. If they are not, you're going to see all the source of water type, water that are there in that specific town. And then the next thing is now to come up with count. So you can decide to use any order as long as you understand what you're trying to solve. Now, this is only specific to this. It is only specific to this. In some other cases, you might have maybe values or even maybe aggregations that won't that will output maybe wrong values if you use the wrong order. If you use the wrong order, in some cases, not all the cases. So the order sometimes it's very, very important as long as you understand what you're trying to solve or even what you're trying to visualize. Okay, so now we have our Q analysis. We want to analyze our data and know, get some specific insights from our analysis of the different queues. So we need to visualize queue time by day or the hour. We need to visualize queue time by day or the hour. Now,
sorry, Musa.
Mm-hmm.
Okay, sorry to cut it short there, but before we go on, please, I have some polls or some feedback forms actually for us to fill. Please, if you can just quickly do that. It's just 4 questions just to answer. I'm pushing it out now for us to just answer those polls. Please let's fill them out quickly and then we continue, please.
Okay. Thank you.
Yeah.
Thank you for that. So let me check where we were.
I'll be pushing them out one after the other. Please, let's just fill them out and continue. So we don't get distracted. It's just few questions.
So, okay. So this is
go
just,
ahead.
Okay, thank you for that. I was waiting for your confirmation. So this is what we are having. This is just a visualization. This is what we've just done. This is what we've just done. Let me check whether we've done. Now, I think we've not done this visualization here, water source count, but I think now for the wells, let me use this to explain. For the wells, you can see the values or even the count of wells within the rural and urban. Within rural and urban, you can see that. And maybe we've not come up with maybe such a visualization, but I think in one way or another, we have that. Like what I said, you don't have to just, the visualization it's not a must for it to be the same, but you can decide to, for this case, if you want to know the number of wells within the rural parts, we just click on maybe rural from first, rural. So you control, then rural, and then you click on wells, and you're going to see all the data that is related to wells on the second visualizations. So after a while, you're going to see that. Yeah, you can now see that. So the count of wells in the rural parts. If you navigate to this, you'll be able to see the number, the count. That is it, 10.9. And I think that is what we are having within this visualization here. That is what we are having, 10.9K for the wells, and then all the others. So you can get these values from what we've just come up with. So our next visualization is queues. So we need to come up with another tab showing queues. Well, we label that. And then we are told we need to visualize queue time by day or hour. So we need to get the specific table that contains queue time. And I think that is time in queue, that is in the visits table. We have time in queue. So let us proceed to data view so that we can see that table. So visits. So we are having this. This is what we have in our case. So we have the time of record and we have time in queue. So this is what we want to use. We want to visualize our time in queue against the time or even the day when that was recorded, when the values were recorded. Okay. So in this case, let us navigate to our report view and then do that. So I'm going to choose the time of record, the time of record. Then I change that to a table. Need to change that to a table. I don't know whether I'm loading in my system a lot.
Musa, are you there or? Uh-oh. Musa, you're muted.
Yes, I don't know what what are you able to see?
Okay, we're just seeing a blank page. I think you're trying to.
Are you able to see anything from your side?
Yeah, we're just seeing the queue. You've opened the queue, this thing,
Okay.
but it's just hanging.
It was actually trying to. I don't know whether it's my network that is poor, but let me hope it's going to be. The page is actually not responsive. Let me.
Okay, guys, while we're waiting for
Musa
you're
seeing the queue editor.
Yes, you're seeing the queue editor, but it's not.
I mean the query editor.
Sorry? Come again, Musa. What's your question, Musa?
Let me. I'm asking whether there is anything that you're seeing from your side.
Okay, yeah. What we are seeing is that you have opened a worksheet queue, and then it's just blank. It's trying to load. Yeah, but it's not showing.
Yeah, that is what I'm waiting for. It's actually, I don't know why. I don't know whether my system is overloaded or what's the reason. Maybe sometimes it might be I don't think it's whether it's network because I changed my net.
Okay.
Let's give it some time.
All right, that's fine. Let's give it some time and see what happens. Maybe you might want to just refresh or
I don't know whether it's the void due to the huge volume.
I think so.
Of I mean, like they're going to finish up very fast and then start sharing again.
Okay. So guys, please, while you're waiting for Musa, let's complete the polls, please. It's quite important to give feedback to our guys, ALX guys, please. We are 34 on the call now, and then only about 20 people have filled. I still have about 14 people yet to fill the poll. Please, let's do that while we are waiting to reconnect.
Select on the relevant table, which is the visit table, and then the next thing would be to select the time of on the time of record column, and then we select on the add column option. So in our case, we are going to proceed to the Power BI query editor, So we have our Power BI under home, then transform. Let me open this. Yeah, then we click on transform to open the Power BI query editor. So we select on the visits table. Okay, let me explain what you'll be required to do. So for the visits table, in this case, we are having you will have a table containing all the columns for the visit table. So you're going to select the time of record. This is the column that we want to use. So you select on time of record, and then you click on add column. That is on the headers, or even let me call it the toolbar. You have the add column. So you click on the add column, and then you check where we have day. So if you want to separate your time of record, or even add another column that contains the day, or maybe the year, or maybe the month, then you use the date option here. If you want to maybe separate this, not separate it, but add in another column from this specific column, but in this case you want the hour, or maybe the minute, or maybe the second, then you use the time in this case. So we are going to select on date, and after selection on date, you're going to see all the values. We have year, you can get all the values for years in the first column, I mean the first three options. Then we have month, you can get all the values for the month. If you want maybe the days of the month, the start of the month and all that, anything about month. We also have week, then we have days. So now you click on the name of day. You click on name of day. Now, some other times, depending on the fonts that you are using within your machine, you might not be able to see this. And for me, it's not giving me an option to scroll down or up. So sometimes you'll have that option depending on maybe the Power BI that you are using. But some other times you may not, maybe you may not see this. So what I did, I had to reduce the font in the font size in my machine, and I had that is how I was able to see this. So you click on name of day, the name of day, and you see another column added to your table. So now you can see we have a column name. But in my case, I already had that. So I don't want that. So I'm going to just delete that column. So if you want maybe to get the hour of the day, then you do the same. You click on time, and then you see hour. This one, you click on hour. And you see another column added here, which will be now the hour of the day. The hour of the day, which is here. So let me delete on this. Let me delete that. Remove column. Remove column. I'm looking for that. Okay. Yeah. So now we've deleted that column. So that is what you're going to do, and then you save. You save changes. You save changes. Proceed to home. Close and apply. In my case, that because I've not made any changes, I'm just going to close. So that will give us it will give us the hour and the day. So now we need to visualize our queue time by day or hour, by day or hour. And we need to find the average queue time per hour. Now I think I lost the other one. Let me just add another worksheet, and maybe call it something else. Let me call it queue time. Let me call it queue analysis. Okay, queue something else. Let me just call it queue. So I need to, or even we need to come up with a visual that shows the average queue time per hour of the day as a line plot for all the days. So we need all the days of the week. So that is the first thing. So into your worksheet, you click on day of the week, that is day name, and you'll be able to see all the days of the week in a table. You'll be able to see all the days of the week. Day name. Okay. Let me just, I don't know. Okay. Let me undo that. I don't know why it's not giving me, okay. Giving me blanks. So I need to check where the problem is. I need to check where the problem is. Okay, so let us work around with these two. We are having incomplete or no data. So let me apply changes so that we see whether we are going to solve this. We are having a problem. I lost the first table. That is the reason as to I'm having these errors. So let's load that. Okay, yeah, now the problem is solved. So we can now select on the day name, the days of the week. You can select on the day name and you'll be able to see all the days. So this is what we wanted. We want to know the average queue time for each day of the week. So we select on time in queue. And in this case, we want the average. So we are going to select on average queue time. Average queue time, and then let me check what else we were trying to visualize. So we wanted to know the average queue time for each day per water source type. For each day per water source type, and then we have average queue time per hour of the day as a line for all the days of the week. So let us add the hour column. Let us add the hour column. Let us add the hour column. And in this case, we need the hour. We don't want aggregations, we just need the hour. And this is what we have. So now we can select online. We can select online and see what we are going to have. So after choosing that, this is what we have. This is what we have. Now, the next thing that we need to ask ourselves, where are people queuing for water? Where are people queuing for water? If we want to answer that question, then we need to select on the day name. We need to select on the day name and the time in queue. Not day name, but the source of water. The source of water, sorry about that. So we need to select on the source of water, type of water source, type of water source, and the time in queue. I think there's also a problem with the type of water source table. Let me also refresh that.
Mr. You're muted.
Yes, I'm actually waiting for finish uploading.
Yeah, that's all right. That's okay.
Yeah, that is why I just muted. These tables are actually taking a lot of time. I think they are now done. So I can we can now move to our table. All right. Now we have this. So as you can see from this, you can see that people are actually queuing for water in only two sources of water, which is a river and a shared tap. That is the only place whereby people are people are actually queuing for water. So if I can visualize this using maybe a pie chart, and you'll be able to see. Now, in this case, we are not going to use a filter that is for the first visit count, because we need to know, like, how long are people queuing for water? How long are people queuing for water? Let me just change this to a table. So what we had here was sum of time in queue. So we can change that to average. We can change that to average, or we can just leave it like that. It's actually not going to really affect a lot. So the average queue time for a river is 17, and the average queue time for a shared tap is 136. So we visualize that, and you can see we only have 2 regions, because the others are not, people are not queuing for water in a well, in a tap in home, and tap in home broken. So we can now, since we know that people are queuing for water in these 2 sources of water, we can now filter this to only include those values. We can filter them to only include those values. So let me click on this. And what we need down here, that is on the x-axis, is the hour. So I'm going to take the hour to the x-axis, and then my legend is going to be the day name. My legend is going to be the day name, and you're going to have something like this. You can see you are having some colors which are very, very bright. You can change that under the filters. That is format option. You can change the opacity of the colors, and also you can change the colors to different other colors. So for this case, you're going to have something like this, such that if I only want to know maybe the average time in queue per hour and day for maybe the shared tab alone, I will just select on the shared tab, and I will be able to see visualization or even a change in the lines, the nature of the lines. If I maybe want this, that is for a river, I will just select on a river, and I will be able to see this. So you can see for a river, it's somehow different. Like most of the people are queuing for water majorly on, this is Tuesday. So most of the people are queuing for water on Tuesday in rivers. Like the average queue time for water on Tuesday for river is this is around what? On Tuesday it's 19.31. 19.31. That is the average queue time for water on Tuesday. And then maybe the lowest queue time for rivers on the 12th hour was in Monday. So if I want maybe information for a specific day, I can just select on the day above here and assume I wanted Wednesday. So I'll just select on Wednesday. That is on where we have the legend. Select on Wednesday, and you'll see data for Wednesday alone. You see data, this red line. If I wanted maybe Friday, I will just select on Friday, and you'll be able to see this line again. So in this case, assume I wanted to know the average queue time on the 10th hour, the average queue time on the 10th hour, where the source of water is a shared tap. So I would just write control, that is click on the control key, click on shared tap, and then click on 10th hour But in this case, before clicking on the 10th hour, I will select on the day. Which day do I want? Maybe I want Sunday or even Saturday. So we select on Saturday. We select on Saturday, and you see the line, I mean the yellow color shown in this case, that is Saturday, and then you click on the hour that you want. And you'll be able to see everything. So for this case, if maybe I wanted a Friday, I will select on Friday, and then I space. This is Friday. Let me select on that again. Friday, and then I need to know the average queue time for the 10th hour. So I will select on 10th. I will select on 10th, that one. Okay, it's very, very hard to select because these lines are somehow interconnected. Let me just expand this and then select on Friday again. So the line showing Friday, it's this line over here. So you can select on the hour. Assume I want the 18th hour. I will just press on Control, then click on the hour, that dot there. And after clicking that, you should see a change within this table here. You should see a change because the two tables are related. Just the same way I said, if I wanted maybe the values for a river, the weighted average queue time for a river, for any specific hour, I will just select on the river and the day. The river and the day. River and then Wednesday. You can see that people are queuing for water in rivers on Friday, Monday, Thursday, Tuesday, and Wednesday. That is when people are queuing for water on rivers. That is what we have from our visualization. And then when are people queuing for water in shared tabs? Friday, Monday, Saturday, Sunday, Thursday, Tuesday, and Wednesday. So almost all the days of the week. But for rivers, people are queuing for water on rivers, in rivers on these days. And you can also see the change in the values. So that is it. That is it. Maybe I can just take you to what I had. So this is the same diagram, but this one is only for a shared tab. So what we've done is an integration of the two for shared tabs and rivers, because we've realized that people are actually queuing for water in shared tabs and also in rivers. So this is an analysis, or even it is a visualization that can be used to answer any question on when people are queuing for water, the time when they are queuing for water, and the average queue time. We also want to know maybe the total time taken for each specific hour. We can change this visualization to accommodate for the aggregate time taken in queue, in that case, for each hour. So I can say that this visualization is more detailed compared to this visualization here. It's more detailed compared to this. Why are we saying it is more detailed compared to this? This one only contains values for a shared tab. The other one contains values for both shared tabs and also rivers. Sorry about that, rivers. If you click on tap in homes, you're going to see 0. In this case, there is nothing shaded, meaning that they were not queuing for water. And then if you click in a tap in home, you can also see a straight line 0. If you click on well, you can also see it's a 0 because people are not queuing for water. Now, our next visualization, we are told we create a visualization of the average queue composition for male, female, and child. So we want to know the average composition of males, females, and children in queue. That is what we want. So we have to select the male. So from our table, we select male. From queue composition, we select on male. We select on percentage male, percentage children, and we also add percentage male. So now we have percentage male, percentage children, and we want to know the average queue composition, the average queue composition. So if we wanted, in that case, if we wanted to know the average queue composition per day, then we would add the day column, the day name. we would also add the day name. And after adding the day name, you're going to have something like this. And the one thing that we know about percentages, these percentages adds up to 100. So we can use a 100% stacked column chart. And if we use a 100% stacked column chart, you're going to have this. So this is now, it shows the sum of percent child. We don't want the sum, we want the average. So we change that to average. We need to know the average percentage of children in Q in the 5 days of the week. So we change that to average. And after changing all that to average, you can now see we have average of percent children, average of percent female, and average of percent males by day name. So that is what we have. If we wanted maybe by day and by hour, we would just add the hour column into this visualization. And if you add the hour column into this visualization, you're going to get a clustered column chart. Let us add this. And then we can change that to a clustered column chart. Yeah, you're going to get something like this. This is by hour. Let me see what we have here. This is not sum of hour. We don't want to aggregate that. So for this case, you can see I don't have the option to change that to maybe the actual hours. So I can use the hour as my x-axis, day name as my legend. So we can move this to, remove that to legend. Okay. Move to legend. It's not moving. Okay. It's not moving. Anyway, so in this case, if you wanted to visualize, the percentage of male, female, and also male, female, and also children, in this case, you're going to have to call, you're going to have this value, that is the male and female and also children, appearing within your legend in that case. Then you're going to have a line chart for males, a line chart for females, and a line chart for children in that case. And then if we want to analyze, visualize them by day, then we can use day in this case as the x-axis in this case. And then we can choose on a start column chart, and then we can decide to split by, maybe we split it by the hour or the day. But the best way is to split by maybe day. So let me take this to small multiples and see whether, yeah, we take that to small multiples, day name, and then on the x-axis we have hour, but it's going to give you something that is really detailed. You're going to have something that is really detailed in that case for that specific analysis. Yeah, this is what I was talking about. So for Friday, you're going to have 3 lines. For Monday, you're going to have 3 lines. For Saturday, same, all the days of the week, and then you're going to have hours down here, if that is what we wanted. But in our case, that is not what we wanted. We were only interested in the percentage of, we were only interested in the average of males, the average of females, and the average of children in the queue for the specific days of the week. So we are going to take this, we move to x-axis. and then we change that visualization. And this is what you have. This is what you have. So as I said, you can use a stacked column chart. You can use a stacked column chart since the averages, percentages add up to 100. So you can have this. And after doing that, this is what you're going to have. After visualizing, this is what you're going to have. And that should be the same as this. Okay. So in this case, we are having, this is the average time in queue. But for this case, it's not inclusive of the gender. It's not inclusive of the gender. What we've done here, we've included the gender, that is male, female, and also children. So if I wanted to know the percentage of males in the queue on a specific day, maybe on a specific day and a specific hour, I will just right click. I will just press on the control key and then click on maybe the gender. The yellow in this case represents male, so I can click on Sunday, then I can click on the yellow, and I will have a curve for that. So if I wanted a specific hour, I would just get the value. So for example, the average queue time for the 14th hour on Sunday was 83.30. That is it. And if I wanted to know where this specific, if I wanted to know maybe the wait time for a shared tab on a Sunday, then I'll click on that. That is males. And then I also click on shared tab. I'll click on that. That is Sunday. And then I will also click on a shared tab. Just a minute. Yeah, so this shows the curve for the entire of Sunday. And then I can click on a shared tab. And after clicking on a shared tab, or even maybe the hour, I can click on hour, and that will tell me the number of people. Yeah, there is no change in this specific table, because in this case 81.53, that is 52.96% of the people were queuing for water, and you can see the other one is 0%. That means that they were coming from a shared tap. All of them were queuing on a shared tap. That is on Sunday. They were queuing on a shared tap, and the other one is 0. That is why there is no change in the values. But if you click on any, you can actually use the control key to click on any of the two values, and you'll be able to get answers to any of the different questions. Okay, I think we are done with that. So the next one, we find the total times queued per province. Total time queued per province. So we select province name from the locations table. We select on province name. Province name. We just minimize this. Now, when the headings are really big, you can just trim them using the format tab. So we select on province name and time queued, time spent in queue, time spent in queue, time in queue. And then we visualize that using a column chart. And this is what you're going to have. That is what you're going to have. So you're going to have something like this. So like what I said, most of these visualizations that we are doing, we are trying to answer all the possible questions that might arise. So for this one, I've not applied any filter. So that means that this one, is inclusive of both the shared tap and the river. If you wanted to maybe include values for the river alone, then for this one, you add another filter. You add a filter whereby the type of water source is a river. You only select on a river and you'll be able to see this. So for example, I've clicked on the river and you can see how the values change. If you select a river and a shared tab, you can see how the values change. If you don't select on any, then it will it will output the values for all of them. If you select a shared tab, you not get anything. A tap in home broken and a well, nothing shows up, because in that case, we are not having people waiting for water or even queuing for water in wells. So this is what you have. This is a visualization. So with this, you can also try to answer specific questions. In this case, assume I want to get to know the number of people who are queuing for water in Kilimani on a specific day. Assume I wanted to know the number of people who are queuing for water in Kilimani on maybe Monday. On Monday, how am I going to do about that? So we click on Kilimani and we click on Monday on the line chart. So after clicking on Monday on the line chart, you're going to see this bar here shown, and also this one is also going to be affected. So for this one, what you are seeing here, this is a percentage of females, the highest, then followed by males, then followed by children, which are the lowest percentage of people. And then for this specific visualization, you can see that the highest people were queuing for water, that is 91% were sharing a tap, they were queuing for water on a shared tap, and then 8.9% were queuing for water on a well, on a river, not a well. You can also do the same. You can choose another one, maybe a Mansi. Let us choose on a Mansi. Let us select on a Mansi. And this time round, we select on maybe Thursday. We select on Thursday. So if you select on Thursday, you'll be able to see the values for Thursday and the average queue time for Thursday for each and every hour, and the percentages from the different sources of water. So for example, you can also add, so we had selected a Mansi. Let me select on a Mansi. Select on a Mansi. And then we select on Friday. Okay, so that is what we've selected, a Mansi, and then Friday. And then you can see the chart here, or even you can see the line curve here that represents the information about a Mansi. So like for this case, you can, if you hover your cursor on the graph, you'll be able to see the percentages. For example, for Friday, the percentage male was 60, percentage female was 33, and percentage child was 33, not 33, sorry, 6.58. So if you select on a Mansi, you realize that there is a different, like there's something different here. Is there anything different? Actually, females are queuing for water. Females are queuing for water than males, and also children. Let me see on the other provinces. We are also having the same. Also the same. So actually, in all the provinces, we can say that we are having a gender disparity. Or in almost all the provinces, women are queuing for water more than females. That is, females are queuing for water more than males, not females. Yeah. So we are done with that. We are done with that. So make sure to include only shared tabs in all visualizations on the queue page. So in this case, I've not included only shared tabs. I've included both. That is for shared tabs and also rivers. So if you want to only have values for shared tabs, you control and then you click on shared tabs. It will output all the values for shared tabs on all these visualizations. Now, what are the key insights from the visuals? Number one, we can see that a Mansi in Amansi, the average queue is mostly made up of men, while on a national level, it is mostly women. Okay, let us try to check on that. So we only want shared tabs. So we select on shared tabs, and then we select on Amansi. So in Amansi, you can see that is for a shared tab. Most of the people that are actually queuing for water, they are men. So what I've done is that I've clicked on control key, control, then I've selected Amansi and shared tab on the two visualizations. Then you'll be able to see these values. So the yellow represents the male. So most of the people who are queuing for water, they are men. That is on for only shared tabs. But if we were to talk about the two, that is for rivers and taps, then I think it will be something different. To be something different, because you'll be having Amansi, only Amansi, and you can see, yeah, in Amansi you can also see, like now the values, even though men are leading in queuing, but the values have grown bigger. The values have grown bigger in this case. Yeah. Then the second insight is that on Saturdays, queues across Maji Ndogo are 40% men. They are 40% men. So let us examine that. Let us examine that. There's a visualization that I've not come up with, this one. In this case, what you're going to do is just like on a national level, you come up with, let me just do that very quickly. Let me just do that very quickly. I don't know whether I have some space. Okay, let me just. So we click on percentage male, percentage female, and percentage child. The three, and then we use a pie chart. I think my visualizations are poorly designed, but that is something that for the purposes of time, let us just work with this. Okay, so this is it. We can actually filter our data to only include values for shared tabs. Because if you look at this, if you look at what we are having here, if you look at this, you can notice that children are taking 10%, females are taking 66%, and men are taking 24%. But from what we are having here, we are having